8 minutes of eighth. Basic data types. I'm back. This is Ron. I'm the developer of eighth. And if you haven't already downloaded eighth and set it up, please do so now so you can follow along. In this episode, we're going to talk about the basic data types that eighth has. We're not going to talk about all the data types. We're going to talk about the ones that you're going to use most commonly. So, just like every other language out there, you can use numbers and strings and a bunch of other things, arrays and so forth. The data types built into eighth are called classes, even though they're not the same as classes that you might be used to from C++ or Java or other object-oriented languages. We call them classes because they enclass a bunch of behavior which is specific to the data type. Specifically, we have things called numbers and strings. Now, to play with this, you can just start up eighth, and we can show you what a number is. So 1.3, type it in just like you would think. It should show up. And when you print it out, you get 1.3. 123, same thing. So a number is pretty much what you expect. Digits, perhaps a decimal point inside, maybe a negative sign. Now, what I just did there was I typed in .s. You're already familiar with the dot word from the previous episode. That means to print something. .s means print the stack. So right now there's nothing on the stack. If I put a number there, and I do .s, you can see that the first position in the stack has something with a class of n. That means it's a number. This is the address of the item, which isn't usually too interesting. This is the reference count, which is 1. And this is the value of the item itself. So when we put in another number and do the same thing, now you see that there's 2 items on the stack. One is the value we just put on, which is 300. And if you look at the address, you can see that it's different than the previous one, which lets you realize that these are 2 separate items. I don't want to mix metaphors too much, but let's look at what happens when you duplicate an item on the top of the stack. Same value, and if you look now, the reference count is 2 instead of 1 because there's 2 references to that very same item. When we drop it, we get back down to 1 reference, which is pretty much what you would expect. Anyway, back to the numbers. We have 2 numbers. If we do plus, then eighth knows that it should be looking at the item on the top of the stack, which is a number, and the next item should also be a number, and it adds them together, and we end up with a result which is, as you can see, an actually different number. Let's clear the screen with Control L. Take a look at strings. Just type in a string just like you would in C or Java or JavaScript even. When we look at that on the stack, now we see that there's an item of class S. And the value is what we typed in, and also a reference count of 1. Now in this case, when we say plus, it's going to complain. And it's complaining that it expected a string but got a number. Why? Because the item on the top of the stack was a string. And so the plus that eighth figured out you wanted was a string plus, but the second item was a number. And it doesn't know how to add a string and a number. And this leads to a very important item, a very important trait of eighth, which is that it does not automatically convert from one class to another, ever. There is an exception, so I shouldn't say ever. But in general, you cannot expect eighth to do what you think it should do if you were not going to be specific. You have to tell it what you want. So in this case, let's reset the stack. Now there's nothing on it. We'll do high with a space after it. And there. Now when we do a plus, it doesn't complain because it knows how to add 2 strings together. And we end up with a separate string, which is the concatenation of the 2. Another feature of eighth which you have just seen with the strings and the numbers is that we often reuse the same terminology, the same words, or I should say similar looking words, to apply similar functionality in different classes. So with numbers and strings, you can add them. You can also add arrays or other things. Next item on the agenda here is JSON. We use JSON, JSON, as our default data format. If you want to declare an array of numbers, you simply use a left bracket, number, comma, some other number, comma, another number, and close with a right bracket. Notice that eighth didn't complain at all. When you do the .s, it tells you that there's an a colon, an array class item, also with a reference count of 1, and there it is. If you want to use an array, there's array specific words. So if we do words a colon, you see you can do a plus, you can do a minus, you can do at and bang, and a bunch of other stuff that's available for you to use with an array. Similarly, you can declare an object using JSON syntax. And here you see, again, the item on the top of the stack is an object, and it's exactly the items that we entered. You will notice that the order of the keys is different, but that's immaterial because we access the items inside an object using a string key, and it doesn't matter what the order it's stored in is, we don't care. Whereas with an array, we do care. So moving on to the last item that we want to talk about, the basic container classes, we've already shown them to you, are arrays and objects. An array is a container class which contains any number of items. It automatically resizes, and they're stored serially. So you access them one after the other or by an index. An object stores a key value pair, and it can store as many of them as you wish, up to the limits of your memory. So in order to access items out of an object, typically use a string to access them. So for example, here on the top of the stack, as we can see, we have the array. If we want to access the value which has the key 1, we use at, and now we see that we have accessed the value that we can see here. It had the value of 1, and now we took out a 1, and we see that this number has a reference count of 2. And the reason for that is that it was contained within this object. So it had a reference count of 1 because that object is holding on to it. And when we did the extraction with the OAT, it put it on the stack. And the stack is a sort of another kind of a container, although a temporary one. And so because it's held in 2 different places, it has a reference count of 2. Let's get rid of those 2 items. And we can do a similar thing with an array. So the at sign means fetch. And here we see that we just fetched the second item in the array. Array indices begin at 0, so 32 here is the item at index 2, which is the third item in the array. There's another kind of a container called a var. So if we do that, we've now stuck the value 32 into the array, into the var x. And if we use at, we get the value back. And what we've just done is we used a bang to store the value, an at to fetch it. And those sorts of words are used in all the different classes that have a similar functionality. So you can fetch or put to arrays, objects, and so forth and so on. In any case, this is just a very quick summary of the basic types. There's other container types stack, heap, queue, and in fact there's a bunch of other types. If you look in the manual, you'll see all sorts of things. There's images and sounds and GUIs and things. But for the basic functionality, this should take you through most of what you need to do. And on that note, we'll say bye and see you next time around.